Aromatic compounds is a little different from some of the molecules we've looked at before, and in fact, aromatic compounds chemically and physically are rather different from both alkanes, alkenes, and alkynes. Most importantly here, they are very unreactive. Aromatic compounds are built on the basic structure of a molecule called benzene. And again, benzene is an example of a molecule that doesn't have any other IUPAC name. It's just called benzene. Benzene consists of 6 carbon atoms in a ring with alternate double bonds placed in between every other carbon atom. So your formula for benzene ends up being C6H6. This is referred to as benzene. Benzene isn't nearly as reactive as typical alkenes. There's something very special about having double bonds in alternating positions that give us that special name. There are some compound derivatives of benzene that have special names. For example, a classic example is the molecule phenol. And notice what I'm doing here is I'm going to not even bother putting in the hydrogen atoms that would, of course, go here, 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 and here. I'm just showing alternating double bonds in a 6-membered ring with just a simple structure, not really even showing the carbons. It's understood there's a carbon at every interval here, at every intersection of these atoms, and then an OH down here indicating it's an alcohol, and we name that molecule phenol. It just has a special name that has to be remembered. Another thing about naming aromatic compounds is when you have 2 substituents. So, for example, if I were to place let's start first looking just at, say, putting 1 methyl group on a benzene molecule. We might call that methylbenzene, but it is almost always referred to as toluene. And this, again, is simply an example of a trivial name that is so deeply embedded in organic chemistry that it's always used. Now, on the other hand, if we have 2 substituents in the name of the molecule in a benzene ring, then we have special naming system here. For example, looking at the dichlorobenzenes, there are 3 structural isomers, one having chlorines in a 1,2 position, one having it in a 1,3 position, and one having it in a 1,4 position. We've already seen how locator numbers might be used to indicate where those are, but we don't do that with the aromatics. Rather than calling it 1,2 dichlorobenzene, we call it ortho dichlorobenzene. And the O here stands for the word ortho. On the other hand, in the 1,3 position, we refer to that as meta dichlorobenzene. And again, the little M here stands for meta. On the other hand, when we have it in a 1,4 position, we call it para dichlorobenzene. And again, the little P here stands for para. So these are special numbering systems that are always used for aromatic compounds. One more example here that also involves something trivial. If I were to put, or a trivial naming system, if I were to put 2 methyls in, let's just say, the ortho positions, rather than calling that ortho-dimethylbenzene, we instead refer to this as orthoxylene, E-N-E, orthoxylene. Just as we didn't refer to methylbenzene as toluene, we simply call it methylbenzene, we call it toluene rather than methylbenzene. So these are important trivial names that are worth remembering. I'm going to throw one more trivial name in here that's fairly commonly used, and that is a single substituted benzene with an amino group, and this molecule is referred to as aniline. And again, these are all just special names for these rather unusual categories of molecules, the aromatic.